Hi, everybody. Welcome to the first part of chapter 3. I call it validity and stuff. We're going to talk about a few different things regarding the basics of how studies are set up and basic kinds of validity. So, the first part of this is going to be ideas of conceptual variables and operationalizations, and then association versus causation. We're going to get into validity in the second part of this. We need to first talk about these basic ideas of what a conceptual variable is, what an operationalization is, and then the purpose of the studies. Then we'll get into different kinds of validity and testing these. Now, remember, the purpose of why we're doing this is to figure out how to best eliminate alternative explanations. I don't know if you remember, but we talked about the idea of confounds and bias. And what we're trying to do is figure out how to minimize and how to take out those confounds and biases in order to make a pretty probable case that one thing causes another, or that one thing is affecting something else. Let's go ahead and start with the basic idea of a conceptual variable. The concept that you care about is your conceptual variable. That's it. That's all it is. A conceptual variable is a variable that you care about. So, for example, let's say that I am interested in love. I want to study love. Love is the conceptual variable. We have a problem. Love is real, it's a concept, but I can't rip the love out of me and stick it on a scale in order to say, oh, you have exactly 3.2 pounds of love. It doesn't work that way. Love is real. Depression is a separate conceptual variable. Jealousy would be a conceptual variable. Memory is a conceptual variable. Any of the concepts that we care about are conceptual variables. Sometimes we also call these constructs. Okay, so a conceptual variable is a construct. We're not distinguishing between those two in this particular class. Those are the same thing. The problem with any of those constructs or conceptual variables that we have in psychology is that we can't rip them out and stick them on the scale, right? So if I want to know about the concept of love, operationalization is how I get at it in real life, the concrete, the operational way of getting at it. There are two kinds of operationalizations: measurement and manipulation. So I have this concept, love. I want to get at it in real life. One way that I do that is to measure it. Now, there's different ways to measure something like love, but the measurement is the way of getting at it concretely. So I can actually get something tangible out of it, something like a number, something that's more empirical, if you remember what we're talking about. The other kind of operationalization is a manipulation. Now, the difference between measurement and manipulation is a measurement is a measurement. I think most people understand that idea of measurement. But manipulation means that I, the researcher, am changing that variable in the participant. I do something to manipulate love. So I'm not measuring how much love you have. I am actively changing how much love you have. Right? I actively manipulate the amount of the conceptual variable that you have. So let's go ahead and start talking about an example. Now, this is going to be really important because we are going to diagram studies throughout this class. All right? And so here's some basics that we need to know about diagramming studies. The basics that we need to know is that number one, conceptual variables are circles, and operationalizations are squares. Okay? Conceptual variables like love will be represented in circles. But the operationalizations, the way you measure or manipulate that down here, whoops, is going to be a square. Let's see if I can, they're not going to let me erase it. There it is. Okay. So, for example, there are two different kinds of operationalizations. There are measurements and manipulations. So let's go ahead and start with a measurement. How do you measure love? How do you, and this is an important point, how do you get, see this arrow that I'm about to write? How do you get from the concept to the concrete? The conceptual variable is the love, and the operationalization is the square. Notice how this arrow goes from circle to square. That means it's a measurement. It's a measurement because we're taking something from the conceptual and making it concrete. All right? So how do you measure love? Well, there's several different ways that you can measure love. So for example, let's say that I could just ask, on a scale from 1 to 10, how much love do you have? 10 being the most and 1 being the least. There's other ways that I could measure love. So for example, I could count the number of kisses. So I look at two people, the number of times they kiss each other, the more kisses, the more love, right? There's other ways that I could measure love. I could measure your heart rate. Okay? And the higher your heart rate, the higher the love. Okay, now notice, that's the concept is the same. Love is the same thing, but there's different ways that I can measure, different ways that I can do this. The operationalizations are all different. They're different kinds of operationalizations. And as I'm going through those, you should say, oh, boy, gosh, is that really a good way to measure? I'm glad that you asked that because that's coming up later on. Don't worry, when we get into the ideas of validity, that's where you should be asking the questions like, is it really a good way to measure love by just measuring the number of kisses that two people share, right? You're saying, well, gosh, sometimes people kiss each other not because of love. Sometimes they kiss each other just because, uh, they live in Portugal and people kiss each other to greet each other, right? Because it's common courtesy, that kind of a thing. Or maybe heart rate's not a great way to measure love because maybe people just ran up some stairs and that's why their heart is beating fast. It has nothing to do with how much they love each other. Okay? These are all different kinds of measurements. The squares, those are operationalization. The arrow from the circle to the square means it's a measurement. And then there's different ways that we could measure the same concept. There's different ways of operationalizing the same concept. Now, so operationalizations are measurements and manipulations. All of these that we've talked about so far, all of these operationalizations are measurements. Let's go ahead and get rid of some of them. And, whoops. And then let's talk about the different kind of operationalization, which is a manipulation. So you can operationalize by measuring, or you, the researcher, can do something concrete that changes the conceptual variable. When you do something that changes the variable, that is a manipulation. You'll notice that in the diagram, it goes from square to circle. The square is the way that I, the researcher, am going to change the concept of love. So what you should be imagining here is something like an experiment. And you're saying, I think that people who are in love, they're more likely to spend money on their relationship partner than someone who's not in love. And in order to test that, instead of measuring how much love somebody has, you actually want to actively change it. I'm going to make people be in love or not be in love. So how would you even do that? How would you make somebody be in love? That would be a manipulation. So let's say that I have two groups, 1 and 2, group 1 and group 2. Group 1 has to take a love potion, right? And group 2 takes no love potion. That would be a manipulation, as long as the love potion actually worked and changed the amount of love. That's a manipulation. I, the researcher, am changing the conceptual variable in the person. So are there other ways we could do it? Yeah, just like there was different ways that we could measure, there's different ways that we can manipulate as well. How else could you manipulate love? Well, let's say that I will use misattribution of arousal in order to make somebody feel in love. So I'm going to have one group of people who runs on a treadmill and another group that doesn't run. And then they interact with somebody of a gender that they are attracted to, and the people who I'm going to make I'm going to X out the run because people who don't run, that's what that means. People who run, people who don't run. So the people who run, they're more likely to have the heart beating fast, and they're going to misattribute their arousal the person, they're more likely to be in love. And people who don't run, they're not going to have the arousal, so they're not going to be in love. Now, just like we did with the measurements, you should be looking at that and saying, boy, I don't think that's the best way of actually changing that, because that's what you should be doing. You should say, hey, is that really a good way to manipulate those things? That's exactly what you should be thinking about. In psychology, a lot of times we get made fun of by other disciplines because we're not a hard science. So I have my father-in-law taught chemistry at the Colorado School of Mines for his career. And he and I have interesting conversations about what makes something a hard science. So number one, it is clear that psychology is a science because we use the scientific method. But number two, are we a hard science? Well, people look at stuff like this love example that I've been giving you, and they're saying, oh, well, you're not a hard science because you can't tell whether you're changing stuff. I don't think that studying love makes psychology a soft or hard science. In fact, I think that studying concepts that we care about, like love, that cannot be directly viewed, cannot be directly analyzed, cannot be directly experienced and put on a scale, that makes it a harder science, a more difficult science, because we have to worry about the operationalizations. We have to worry about how well we are measuring or manipulating certain concepts. This entire class is about that basic idea, right? It's about whether or not concepts are changing concepts, and whether or not operationalizations are changing or being measured by other concepts. That's the entire basis of what we're talking about, how well we do that process. And we in psychology have a difficult time sometimes in coming up with unique, creative, and effective ways of operationalizing variables. It doesn't mean we're not a science. It means that we have more difficulties in operationalizing different studies that we do and the conceptual variables that we care about. All right, answer this question. A study must have a measurement, a manipulation, or both. The answer is a study must have a measurement. It doesn't have to have a manipulation. So you're like, well, wait a minute, what are you even talking about? Well, I'm glad you asked, because we have different kinds of studies that do different things. Particularly, we need to talk about the difference between association claims and causal claims. Association claims mean that one conceptual variable is associated with or correlated with another variable. A causal claim means that one variable causes another variable. One conceptual variable causes another conceptual variable. Now notice how those are different, all right? One is that one is associated and the other is the other one causes. So for example, let's say that my theory is that love causes people to spend more money. So one conceptual variable is love and the other is spending money. That's the other conceptual variable. If I'm doing one thing causes the other, being in love causes the change in how much money you spend, that's a different question than do people who are in love tend to spend more money? If you're saying they tend to spend more money, that's an association claim. We don't know if it's because the change in love causes a change in spending money. We just know that they're associated. It could be that they cause it, could be that they're just, associated. When we are looking at association claims, we are looking at studies that are correlational studies. A correlational study measures and measures. So you see measure and measure and measure, meaning you measure one variable and you measure the other variable. You measure how much love you have for somebody, like say on a scale from 1 to 10, and then you measure how much money you spend on that person, like on a scale from how many dollars did you spend in the last week, that kind of a thing. All right? That is an association claim. You measure one variable, you measure the other variable. It is not a causal claim. In order for us to say that one thing causes the other, we have to run an experiment. An experiment is only an experiment when you manipulate one variable and then measure the other variable. You manipulate an independent variable. An independent variable is the one that you manipulate. That's what an independent variable is, all right? And it causes the change in the dependent variable. The dependent variable is the outcome variable. Independent variable the one you change, the one you manipulate. You, the researcher, is changing and manipulating. And the dependent variable is the one that is being changed, right? So for example, in the experiment that I just barely gave you, the experiment would be I change love, I manipulate love, and that changes how much money you spend on that person, right? I would manipulate love and then measure amount of money spent. Manipulate and then measure. Okay, notice how that's a lot different than just measuring how in love you are and measuring how much money you spend. Manipulation is in an experiment. You'll notice that whenever we did these manipulations, when I was drawing them out for you, I always gave you two different groups. Remember that a comparison group is important here. The comparison in this case would be something like a control group and experimental group, right? So somebody who runs on a treadmill would be the experimental group. The control group would be someone who doesn't run. Now, for an experiment to be an experiment, you do not have to have a full control group, because most of the time when you think about a control group, you're saying it's somebody who doesn't experience anything. Well, in reality, all you need to do is to have a different amount of the manipulation, okay? A different amount. So for example, if I had one group that took, half a teaspoon of the love potion, another group that took half a cup of the love potion, that would still be a manipulation because I would have different amounts of love. A little bit of love from the teaspoon, a lot of love from the cup. And that would change. That would still be a manipulation, even though I didn't have anybody that was a full control group. Let's talk about these associations versus causal. And there's one other that we need to talk about, and that's frequency. So a frequency claim is just how many times one thing happens, right? So when I look at a group and I say, all right, what percentage of the people are in a relationship? That's a frequency claim. So if 1/3 of the class is in a romantic relationship, that would be a frequency claim. That's different than association, where I'm looking at one variable and how it's associated with another variable. All right, so for example, frequency is just what percentage of this group is in a relationship. A correlation would be I measure how much love people have for a significant other, and then I measure how much money they spend. And that's different than the causal, experimental causal claim, where you have to manipulate how much love somebody has by, for example, giving them love potion, different amounts of love potion, and then measuring how much money they spend on their relationship partner. So frequency claims, association claims, and causal claims. All three of those are different, and the frequency claim is just measuring one variable. Association, you measure one variable and another variable in the same people. And causal is you manipulate the variable and then measure those people for a dependent variable. So let's do an example. Let's do an example of the difference between an association claim, which is done with a correlational study, and a causal claim, which is done with an experiment. Those are the ones that we're going to mainly be talking about. So let's say that I think that, let's try and do something a little bit different. I think that your facial expression will affect how will affect your mood. All right. So what I am saying is I think that there's this concept called your facial expression, right? And I think there's this other concept called mood. So one conceptual variable is your expression, and the other conceptual variable is your mood. All right? I need to have an operationalization of each of these in my study. Okay? And how I operationalize them will depend on what kind of study it's going to be. Remember, in a correlational study, which can test an association claim, I will measure one variable, measure expression, facial expression, and then I will measure mood, measure and measure. So let's say for this study, I'm going to make a correlational study. I'm going to measure your facial expression. Notice how the arrow goes from circle to square. I know that's a measurement. How am I going to measure it? Well, let's say that I have observers. And the observers are going to measure. They're going to say, well, how much is that person smiling? I think that person's smiling at about an 8. All right? So observers are going to look at your facial expression and determine how much of a facial expression you're using. And in mood, I'm going to do on a scale from 1 to 10. That is, I ask you, how happy are you? With 1 being not very happy and 10 being very happy, right? I have measured the facial expression. Look, it goes from circle to square, right? I had observers observe how much you're smiling. And I've measured mood from circle to square, right? And I did that by asking on a scale from 1 to 10. The relationship between these variables then can go either way. Because this is an association claim, notice how the arrow is going both ways. Because I'm just measuring how associated they are. I don't know if your expression is causing your mood, or your mood is causing your expression, or they're both causing each other. I don't know. I don't know what's happening with that. Could be either way. And so this study would be a correlational study. This is a correlational study. The way that I know it's a correlational study is because there is a measurement of the first variable and a measurement of the second variable. The association between the two conceptual variables could go either way. It could be that expression is causing mood, or mood is causing expression, or both. We don't know. That's why we have the arrow going both ways. That is a correlational design. It's a correlational study. And a correlational study can only give us an association claim. It can only say that they're associated with each other. It cannot say that one thing causes the other. There is a very important statement that all of science uses, and that is correlation does not equal causation. Correlation does not equal, I'm going to write it down. Correlation does not equal causation. Just because your expression and your mood are associated, they're correlated with each other, does not mean that your expression changes your mood. It also doesn't mean that your mood changes your expression. We don't know. That is why you would have to run an experiment. So let's change this to an experiment. Let's change this to an experiment. So in order to do this, there's a few things that we need to do. Number one, an experiment is always that you manipulate an independent variable and you measure a dependent variable. So let's say that my hypothesis is that your facial expression changes your mood. Specifically, to make it a hypothesis, I should have a prediction. People who are smiling will have a happier mood. Notice how that was a hypothesis because it is a specific prediction. In order for that to happen, then, I am looking to change, let's change a few things here. Okay? Let's change a couple things. So this hypothesis says, I think the expression changes the mood. Notice how now it is going from one conceptual variable to another. The expression is changing the mood. It cannot go the other way because it needs to be causal. The expression has to cause the change in the mood. The expression is the independent variable. The mood is the dependent variable. When you look at a hypothesis, you can tell what the independent variable is. It's the one that's going to change the dependent variable. A happy face is going to, a smile is going to change the mood. And what that means is that for this, we need, instead of having a measurement, we need to have a manipulation. We need to do something in real life in this operationalization that changes people's facial expressions. And we have to do it so that we have a comparison group. So that means that we can do this in two different ways. We can have each person both smile and not smile, and then see how it changes their mood each time. Or we can have one group smile and one group not smile. Either way, we have to have the comparison. So one group, I'm just going to say, smile for 30 seconds straight. And the other, I'm going to have it be a control. Okay? So half the people are said, for the next 30 seconds, you have to smile. Like that, for 30 seconds. And the other one, they're not told anything. Okay? That would be an experiment. We, the researchers, are doing something in real life to change the expression. We are manipulating the expression. And because we are manipulating an expression, we can say, hey, the expression actually changes the mood. It has to, because it goes in that order. This is a diagram of the most simple experiment right here. A manipulation, changing a conceptual variable, which is the independent variable, and that independent variable causing a change in the dependent variable, which is measured. All studies require the measurement. You have to have that measurement in the end. All of them have to have the measurement. But in an experiment, you manipulate the independent variable and you measure the dependent variable. Okay. One more thing that we need to talk about with associations. Remember, this is correlational designs. When we do an association study, a correlational study, we show the relationship between the two variables using a scatter plot. Now, you should remember, you've seen scatter plots in the past. And the scatter plot, what it does, it takes each person and gives them a dot in terms of how much they have of each of the two different variables. And then what we do is we look for a line of best fit to see what the association is. If the line is going up, as one thing goes up, the other goes up, that means we have a positive relationship. If, as one thing goes up, the other goes down, then we have a negative relationship. And if the line is flat, we have no association. There's no correlation. So what this looks like, just to remind you how it looks, is let's go ahead and make a scatter plot. A scatter plot uses an X and a Y axis, and we will have, in this case, let's have the amount of love over here, right? Remember, they could have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 amount of love, right? That's how we were measuring it. And over here, we can have money, okay? How much money you spent. So there's $0 in the last week, and here's $1,000 in the last week, right? $0 to $1,000. So let's say that we have this one person. We'll have 10 people here, okay? Person number 1 loves their relationship partner at a 2 and spent about $5 on them. So they'd be about right there, okay? The second participant here has a love about a 5 and spent about $500 on their relationship partner, so they'd be about right. So this dot represents a love amount of 5 and amount of spending at about $500. All right, person 3 loves their relationship partner at about a 4 and spent $800 over here. And person number 4 loves about an 8 and spent about $900 right there. Okay, person 5 was a 3 with $30 right there, and person 4 was loves. This is not person 4, person 6, I guess. Loves at a 4, and etc. So I'm just going to put a couple more dots in here. See how we are doing with our specific scatter plot in this case. All right. Oh, one more person. This person loves it at 10 and spent about $900. Okay, good. By the way, I'm not saying that you have to spend a lot of money on the people you love. That's not what I'm saying at all. So what we're doing then is, if we're looking for the relationship, we're looking for what's called the line of best fit. And the line of best fit would be a line that says how well, what's the line that we can have the shortest distance between all of these different spots. And it would be probably something like this-ish. Notice that this line that we just drew shows that as love increases, money increases. That is a positive correlation. A positive correlation. As one thing, love, increases, money also increases. That is a positive correlation. Conversely, let's do the same thing. Let's get some different, put in some different dots here. Let's say that you love at about 9. Okay, this person is over here. Erase these two down here. Let's say that it looked more like this. Notice how if we put a line of best fit on this, it looks something like that. As love increases, money decreases. That is a negative correlation. Negative correlation. And if it didn't matter at all, then our dots would look something like this. Dots, dots, dots. Notice how as one thing goes up, the other doesn't necessarily go up or down. Notice how the line of best fit would be flat. That's no correlation. No association, no correlation. It's a flat line. All right? Okay. Let's go ahead and end with a question, and then we will end this portion of the chapter. Which of these is a manipulation? Let me read them to you, and you'll see it again on your screen. We ask half the students to eat hot sauce and the other half to eat ice cream. The second is each participant takes a test once with a blindfold on and then once without a blindfold. And C is half of the students hold puppies and the other half hold snakes. And the last option, D, would be all of these are manipulations. So which one of these is a manipulation? The answer is that all of these are manipulations. All of these are manipulations. Because we, the researcher, are changing it in one group or another, or in the case of B, each participant has the manipulation happen within themselves, right? They take the test once with the blindfold on, and then once with the blindfold off. Okay. A measurement is always from circle to square. The conceptual variable is being measured. A manipulation is always from square to circle. In this case, all we have is one variable. So for example, we're not sure what these variables are. We know what the manipulation is in this case. So let's say that I don't know, pleasure is the conceptual variable, and eating hot sauce would be low pleasure, and eating ice cream would be high pleasure, right? If we ask half the students to eat the hot sauce, which would be low pleasure, half to eat the ice cream, then we are manipulating pleasure.